Hello friends, welcome to the world of discrete mathematics with me Kunal Aire on my YouTube channel. Here we are going to learn about all the concepts related with the discrete mathematics. Let's start with the new topic of the set theory is types of set. So these are the all types of set. First one is empty set. Second one singleton set. Third one finite set. Fourth one infinite set. Fifth one subset. Sixth one proper subset. Seventh one equal set. Eighth one power set. And the last one is a universal set. Let's start with the first type of the set is a empty set. Empty set is also considered as a null set or void set. A set containing no elements is called as empty set or null set or void set. It is denoted by phi or open and close curly bracket. Let's take an example. A is equal to x such that x belongs to capital N. Capital N stands for natural number. 1 less than x less than 2. Now here we have to find out the all elements, that is natural number in between 1 to 2. So we get A is equal to empty set. So what is empty set? A set containing no elements is called as an empty set or null set or void set, and it is denoted by phi or open and close curly bracket. Second definition, that is singleton set. Singleton set means a set which contains only one element. It's considered as a singleton set. For example, let A be a set of all integers which are neither positive nor negative. Set of all integers which are neither positive nor negative means we get A is equal to 0. So we get only one element. So this set A is considered as a singleton set. Now take another example. B is equal to captain of Indian cricket team. So we get Virat Kohli. So again this set contains only one element, that is a Virat Kohli. So B is again a singleton set. Next definition, that is a power. Next definition, that is a finite set. The empty set or a set which contains finite number of objects is called as a finite set. For example, set of letters in the word nature. So you get A is equal to Nature. Set contains countable elements. So A is considered as a finite set. So definition of finite set is the empty set or a set which contains finite number of objects. Next definition, that is an infinite set. A set which is not finite is considered as an infinite set. For example, capital N, capital W, N stands for natural number, W stands for whole number, then capital R, that is a real number. So these are the infinite sets. So there are two more important points related with the infinite set. That is, an empty set is a finite set. But if we consider all the remaining set, that is natural number, okay, that is integers, whole numbers, real numbers, otherwise set of all points on the circle are considered as an infinite set. Now the next most important definition of the set is subset. Subset means let's consider the most important definition, that is a subset. Let's consider the two non-empty sets A and B. Non-empty. Non-empty means contain some elements. Contain some elements. If all the element of A belongs to B, that time A is a subset of B. A is a subset of B. Otherwise, we can define as let set A is said to be a subset of set B if every element of A is also an element of B, and we write it as A is a subset of B. Subset has two properties. The first one is empty set is a subset of all sets. Empty set is a subset of all sets. And the second one is every set is a subset of its set. These are the two most important properties of the subset. Next definition, that is a proper subset. A non-empty set A is said to be a proper subset of the set B if all the elements of set A are in the set B. The most important condition in the proper subset is at least one element of B is not in a A. Let's take an example of subset and proper subset. Let A is equal to 1, 2, 3. B is equal to 2, 3. Now for the given condition, all the element of B belongs to A. So B is a subset of A. Now for the given condition, A is equal to 1 to 3, B is equal to 2, 3. Now look, 1 does not belongs to B. Means at least one element of A does not belongs to B. That time A is a proper subset of B. A is a proper subset of B. So what is proper subset? A non-empty set A is said to be a proper subset of set B if all the elements of the set A are in the set B, and most important condition, that is at least one element of B is not in a A. And one more point, for the proper subset, A does not equal to B. Next definition, equal set. Two sets are said to be equal if they contain the same elements. That is, if A is a subset of B and B is a subset of A, means A is equal to what? B. For example, A is equal to A, B, C and B is equal to B, C, A. In this case, A is equal to B because A is a subset of B and B is a subset of A. So A equal to B. Next one is power set. The power set of A is denoted by P of A. The set of all possible subsets of given set A is called as a power set, and it is denoted by what? P of A. For example, A is equal to A comma B. So we get P of A is equal to A, then B. Every set is a subset of itself and empty set is a subset of all sets. These are the two properties of subset. So P of A, we get 4 elements. Now let's consider another example. A is equal to 1, 2, 3. So we get A is equal to 1, then 2, then 3, 1, 2, 1, 3, then 2, 3. Again, two properties. Every set is a subset of itself and empty set is a subset of every set. So we get 8 elements. So there is one formula to find out the total number of elements present in a power set is 2 raised to n. So total number of elements in a power set is equal to what? 2 raised to n. Very simple definition of power set. The set of all possible subsets of a given set A is called as the power set of A, and it is denoted by what? P of A. The last definition, universal set. If in a particular discussion all sets under consideration are subsets of a set, consider the set as a U or X. In general, universal set is denoted by U or X. That time U or X is considered as universal set for that discussion. For example, if we consider natural number, if we consider whole number, so natural number and whole number are a subset of real number, So in this condition, capital R, that is a real number, is a universal set. So simple definition. Universal set means what? If in a particular discussion all sets under consideration are subsets of a set, say U or X. So in that discussion, U or X are considered as a universal set. Okay. Now in next lecture, we'll see all the operations related with the set. That is complement of set, union of set, intersection of set, difference between the sets, and symmetric difference. If you like my video, then like it, share it, and subscribe to my YouTube channel. If you want more videos related with the discrete mathematics, then don't forget to click on the bell icon button.